So, this topic here, you would have started before lockdown actually occurred. So I know Kia had done some of this stuff with me already, and you guys probably would have done it at some point as well. So just conservation of mass and relative formula mass, and they are really easy things to kind of get correct in exams, and you get easy marks for it. So just where it fits in, so it's chemistry topic 3, quantitative chemistry, and that's tested in paper 1. So if your outcome, then we're going to look at what conservation of mass is, which is, you cover it key stage 3 and at GCSE. And then we'll look at why mass, sometimes it seems like it changes in chemical reactions when it actually doesn't, but we'll look at the reasons why, and then going to move on to relative formula of mass, look at all compounds. So first of all, conservation of mass.
Oh, look who it is.
Where am I sitting?
There's no room.
I've seen before.
He won, isn't it?
Yeah,
I have to do. What's that one there?
that's Alfie's.
Oh, that means I have to do
No.
Okay. Right. So conservation of mass. Then yeah, paper 1, chemistry, topic 3. Anyone remember what it is? No. Been away for too long. Lockdown.
Yeah.
Forgotten everything. It's quite simple. Okay, it's just you have to remember that mass is never gained or lost in a chemical reaction. Okay, so if you mix two chemicals together, at the end of it, they'll still be there. They may change slightly, but nothing new will be created. No new elements will be created in there. It will just be kind of rearranged almost. So just a couple of other points as well. So when a reaction occurs, the atoms in the chemicals are rearranged to different compounds. No new atoms or elements are created, or none of them can disappear either. Okay, so for example, if we look at pens, the creation of water, okay, nothing new's happened there other than that these two elements are bonded together to make this. There's no new elements in there. There's still H's and still O's there. Okay, so still hydrogens and oxygens. They're just the reactions happen to make them bond together. Okay. So, a couple of examples then, and these are kind of like questions you may get asked as well about conservation of mass, giving you some kind of values in there as well. So, basically what happens is you have to remember that the arrow in that equation there, this here, the mass has to be the same before the arrow and after the arrow as well. Okay? So, these are just random numbers as well. I'll put grams in there, it could be anything. Tons, whatever. So, for example, we've got 20 grams of hydrogen, missing the amount of oxygen we need, but we end up with 50 grams of water at the end. What's going to be a missing value? 30. Really simple, right? Okay, simple maths kind of base thing. When we go to this one here, it gets a little bit more tricky. Okay, you sometimes may have to work backwards. Okay, so you have to total up. Remember, before the arrow, after the arrow have to be the same amount. So, if you get a question like this, it's always best to start on the side that you've got two values for. So how much we've got over here in total on this side? 150. Okay, how much we're going to have over here in our missing value here? 50. Okay, that's kind of the basics for it. Now, like I said at the start, you have to have the same amount as you started with as what you end with as well. However, in some reactions that you do in class, you may not see that. Okay? Which then kind of completely rules out that whole idea that mass is conserved. So, this here then.
Wait, I'm sitting there.
So, we've probably done this before. Magnesium oxide being made, take a piece of magnesium, put it in a Bunsen burner, reacts with oxygen, burns really brightly. Everyone's seen that before? Probably done it. Right. So with that there, as we heat up the magnesium, okay, it starts to bond with the oxygen that's in the air. from making magnesium oxide. Now, if we started with 48 grams of magnesium, say, in our example on the board, but we end up with 80 grams of magnesium, that there, because you can't see the oxygen, you're not exactly weighing it, because you don't know how much you need to put into the reaction. The magnesium will do that itself. So, we've only weighed one of our reactants at the start, which is magnesium. We haven't weighed oxygen as a gas because we can't, it's in the air around us. So, but the mass of the oxygen, obviously, then you can work backwards from your product you make. Okay? So what would our missing value of oxygen be?
32.
Good job. 32. Okay? So sometimes you can see that if we just had that there, it looks like the magnesium has increased, but with something. Okay? But for it to increase up to 80, it's reacted with 32 grams of oxygen. Okay? Like I said, these numbers are just random numbers. They could be different in an exam question. So, a little thing at the top there. So, an increase in mass when your reactant is a gas. So, if you react something that is a gas with another element, you should see an increase in the mass. Okay? But it has to be the same either side. Okay? However, that is different if your reactant is a gas. So, you get a decrease in mass when your reactant is a gas. So if one of the products when your product is a gas, not a reactant, a product. If one of your products is a gas, you sometimes see a decrease in that. So, for this to happen, calcium carbonate is a powder you can then kind of thermally decomposition. Okay, so if you heat it up, you'll make calcium oxide and produce carbon dioxide as a byproduct as well. So your product now, one of your products is a gas, the other one is a solid. So, why might we see a decrease there? So if we put some calcium carbonate into a boiling tube, we heated it up, and we ended up with 56 grams of calcium oxide, it seems like we've got a decrease in mass, when we know it should add up back up to 100 grams. Okay, so we've got a missing value there, but why can we not calculate that? Why does it seem like there's been a decrease? What's happened to that carbon dioxide? Think about a boiling tube. Okay, imagine this is our boiling tube.
Evaporated.
Not just evaporates as a gas, but what's at the top of it?
Oh,
A hole. Yeah? So the top of a boiling tube is a hole. As you heat it up, that gas is going to then what?
Go on.
Escape out of the boiling tube, right? So that's a kind of another little question you may get asked of why does it seem like there's been a decrease in mass? Okay, if there's not a bung in the top or a covering in the top, gas will escape. Okay? So there will appear to be a decrease in mass because one of the products is a gas, so it's not weighed with the rest of the solid product, and like Jake said, it will escape out of the top. So your missing value then there, 44 grams. Okay, so it's all about just having the same before the arrow and after the arrow.
it's just switched around.
Yeah, and sometimes you have to work backwards, but it's basically, as long as you remember what we've got before, if it's 100, after the arrow has to be 100 as well. Right, moving on to relative formula mass. Now, this is where it kind of links back with Mr. Michael's lesson a couple of weeks ago. So if you haven't watched that video, if you're doing it from home, make sure you go back and watch that before you do this up. So, like I said, Kia's done this with me, and you guys have probably done it as well. They're really easy to do. Okay, all you need is a periodic table, which you get in your exam, and you're basically just calculating the mass of a compound. Like I said, they're very easy, but you must use your periodic table and use a calculator as well. Okay, so when we come to do some of these in a minute, I'll get you to log on and use the calculator on the computer. Right. Oh, we've already. So, let's just nip back to Mr. Michael's lesson last week, or 2 weeks ago. Two numbers on a element. What are they?
On there.
Yep. And? Mass. Good. So you have two numbers, atomic and mass number. Now, for relative formula mass, all you need to worry about is that top number. Okay, the mass number, or the bigger number on your periodic table for each element. Now, it is really, really simple to do. And I've broken it down into 3 really simple steps. And we're going to have a go at doing these in top book in a second. We'll go through them on the board as well. So, first of all, so basically you'll be given a compound of some kind. on a formula of that. Okay, so use a formula like CO2 because it saves writing carbon dioxide every single time. It's a shorthand version of writing it. So you break down the new compound into individual elements. So every capital letter makes a new element. That's the easiest way I like to remember it. Okay, and I'll show you that in a second. Number 2, find the mass number for each element using a periodic table and how many you need. So you may need sometimes 2 of one element. For example, CO2 means you need 2 lots of oxygen. Okay? And then all you do is add all the numbers together to calculate the overall relative formula mass. Really, really simple. So, let's have a go at 2 examples. So, in your books, and if you just open your books and give yourself a little bit of room around each one, but just get those down there. Okay, so 2 examples. We've got. No, I don't think so. Right, we shot this. The camera.
Oh!
That's going to look funny.
I forgot about that. Do you know where the books are?
No, that's pretty close. Right, so if you get those down then. Right, so, Kia, can you remember doing these? No, brilliant. Right. You're going to be our go-to to get some answers to this. So you will need, obviously, these into your book and your periodic table in front of you. So like I said in the simple steps, okay, once you get given one of these, break it down into the individual elements. Okay? So, people do this different ways. I just would draw a dotted line in between the C and the O. Okay, so that there are 2 individual elements. Okay, that O is a capital O, which means it's another element. Okay? So, we'll split it into 2. So we've got, what is the element with the symbol C?
Carbon.
Carbon. Perfect. So, on your periodic table, find carbon. What is the mass number of carbon?
12.
12. So, make a little note of that underneath the C. Okay, you show a periodic table in front of you. Okay, you find an O. What is O? Oxygen. What's the mass number of oxygen?
16.
16. And you do your third and final step is you add those 2 numbers together, which gives you an overall relative atomic mass of
28.
Who's that? Jack?
28.
28. So the way you would write it is you have a capital M and a little r, and then it gives you a relative formula mass of 28. Perfect. Huh? So that means relative mass. Okay? Okay, so for our second one, okay, we've got NaCl. So, this one's slightly different. So again, split it in half or into individual elements. So we've got Na, remember if it's a capital and then a lower case letter, that's one element, okay? So you split those in 2, leaving you with Na and Cl. So, what is Na? Sodium. What's the mass number, please? Megan. The mass number of sodium, please. 23. Good. Make a little note of that underneath sodium. What's Cl?
Chlorine.
Chlorine. What's the mass number of chlorine?
35.5.
35.5. Good. Okay, and then all you do is you add those together to get your answer. Okay, what have we got?
58.4.
Good, so then you have your capital M, little r, 58.5. Okay, everyone see how we get into those, yeah? Superb. Well, we are going to do some of these on your own in a little bit. I'm going to go through another 4 examples, but I'll get a little bit harder as we go through. Okay? Okay, just rub these off. Right, next 2 then. So these 2 then now have got little numbers in them. Okay, so you've got H2O and you've got H2SO4. Now,
Means 2 hydrogens, right?
yes, so like Jake said, if it has a number after the element, it is for the element before it. Okay, so H2 is for hydrogen. Okay, so if you get those down into your books then for me, and then you just do the same kind of simple steps as we did before. We'll break it down into the individual elements and then go from there. So like Jake said, H2 is 1 on its own. Okay, and you've got O on its own as well. So, H is what element?
Hydrogen.
Hydrogen has mass number of
1,
1. Okay, but you've got 2 hydrogens, so what's your mass number going to be?
2.
2, good. So you've got 1 plus 1, which gives you 2. O is oxygen, we had that last time, and the mass number was what? 16. Okay, add those together,
18.
gives you a formula mass of 18. Perfect. Okay, H2SO4 then. Write it, break it down. It makes it much more easy for you to kind of understand. So, again, we've got H2 there. So we have a little dotted line between H2. S and O are both capital letters, meaning that they are different. So you've got S on its own and O on its own. So this time we've got 3 now to look for. So, start again, we've got H2, which is the same on the one we just did for water. Okay? So we have 1 plus 1, because they're the mass numbers, and we've got 2 of them, which gives us a mass number of 2 for our hydrogen molecules there. S is what?
Sulfur.
Sulfur, and it is what, Matt? 32, good. And then O is oxygen, and the mass number is what?
16.
But
Times by
4.
we need 4 of them, so Olivia, what'd you do?
times by
Good, so you do 16 times 4.
Can't do it off the top of
Use a calculator. It's a calculator on your computer. Matt, you're logged on.
64.
Sophie? 64. Okay, so then what you need to do is you add your 2, your 32, and your 64 together to give you
98.
okay, relative formula mass of 98. Well done. Okay, you don't have to remember any kind of values or measurement values for this. Okay, it'll just ask you what the relative formula mass is, okay? Nice and simple, okay? Anyone struggling with these at the moment? No? Okay, cool. Last 2. Okay, these ones get a little bit more trickier now. And are probably the worst ones you could possibly get, but they're not actually that bad because you've done these ones that are easy enough. Okay, brackets. So, just write them down first of all, give yourself a bit of room so you can do them. Make sure you put the brackets in the right place as well, please.
So they have to do the bracket first. This one's
We'll get to that in a second, I'll come back to you. But yeah, get them down first and we'll talk about how we do these first of all. Okay, so what we've got then is our first one is CA, and then we've got OH in brackets, and then 2 just outside the brackets. Okay, our second one, ZN, we've got NO3 inside the brackets and 2 on the outside of the bracket. So, Kia, you just said something to me just a minute ago. What did you say, please? Nice and nice, we can hear it on camera.
then you do the brackets first next time.
Good, so deal with the brackets first, and then worry about the rest of it after. Okay? I don't know if I do that in maths, you deal with the brackets first and then Yeah, but it's probably the easiest way to do it here. So, again, once you've got it written down, split it up into your things first of all. So, we've got CA, O and the H, but let's deal with the brackets first. So, first of all, inside the brackets we've got O, which is oxygen, which is a mass number of what? 16. Okay, H is hydrogen, which is 1. So, the easiest thing to do is work out what the mass is inside the bracket and then times it by the numbers on the outside of the bracket. So, inside the bracket, our total is 17, Matt. Good. Okay, so, but we need 2 lots of that 17, which will give us what? 34. Good. So now then what we've done, if you just look at the board now, we've dealt with this whole bit here, and we've got our overall number for that part of the formula there at 32. Okay? Then all we need to do is just find Ca, which is calcium, and the mass number of 40. And then all you need to do is add those two numbers together.
34 inside.
Sorry?
Yeah, 34 plus 32.
34, sorry. My mistake.
74.
And it gives you a relative mass of 74. Cool. Right, I'm going to split this next one up for you and then you can do it by yourselves and we'll see what we get. So, you've got Zn, NO3. So like I said, work out what's inside the bracket as a total times by the outside and then finish off the first part.
We get a calculator in our test.
Yeah, there you go, calculator. And that's why I said on the things, always use a calculator, just to double check. Okay, you'll have people that will just do it in their head and then miss by a number or two. Okay, and then it's going to be an easy minus miss. So work out what's inside the bracket first as a total, times it by the outside. Then that's the whole bracket complete. And then you should find Zn and add it to that.
Is it the top number? Or
So the mass number gets to the bigger one out of the two. Yeah, always the bigger number when you're working out relative formula mass. Yeah, clue's always the name. Relative formula mass, just look at the bigger number. Okay, so let's deal with the bracket first then. So first of all, in our bracket we've got N, which is nitrogen, which has a mass number of what, please?
14.
14, good. We've got oxygen, which is a mass number of 16, but what do we need? 3 lots, which is what? 48. Okay, add those together. Gives you 62. Good. So inside of our bracket, the mass total inside our bracket is 62. Say, Jake?
Yeah.
Yeah. But now what do we need to do?
You need to find.
Have to times that by 2. Good, because you've got 2 on the outside, which gives you total of what, please, Matt? Okay, 124. Okay, so that 124 is for the brackets and the number after it as well. Okay, so that whole part here is 124. Now we need to do is just work out the rest, which is Zn.
Times 48 by 2. Right. Is it 48 by 2?
Literally, whatever the total is in there.
Yes.
So-
48 plus 14, then you get 62 times that by 2.
You haven't added that onto it. Okay, then Zn zinc, which has a mass number of
65.
65, and then you add those two numbers together. Gives you what, Matt?
189.
Good. 189. Perfect. Everyone get it on? No? Yeah? Yeah? Yeah?
Yeah, I just didn't see the 2.
Two and then you remember that one on the end, okay? Always remember if you've got a 2 after, it's got to be times by the total that's inside of the brackets.